Equivalent weight. In previous segment of equivalent weight, we have discussed about the equivalent weight of elements, compounds with respect to displacement or combination of hydrogen, 1 parts by mass, oxygen, chlorine, silver, etc. In this part, we will discuss about the equivalent weight of acids, of the bases, salts, oxidant, and reductant. So first of all, we will discuss about the equivalent weight of acids. What is an acid? As per Arrhenius' concept of acid and bases, Arrhenius' concept of acids, those that have tendency to release H plus in its solution, hydrogen ion, those compounds that have tendency to release hydrogen ion in its solution behaves as acid. So on the basis of number of hydrogen ion released, the acids are categorized as monoprotic acid, those in which one H plus is released. Mono means one, like HCl. When ionized, get S plus plus Cl minus. HCl, hydrochloric acid, is a monoprotic acid because it releases one proton, one hydrogen ion in its solution. So equivalent weight of an acid will be its molecular weight divided by n dash. What is n dash here? It is basicity of an acid. What is basicity? Basicity is number of H plus that neutralizes OH minus ion of base. Number of H plus released by an acid to neutralize hydroxyl ion of a base are called basicity of an acid. So here basicity of this HCl is 1. Why? Because one proton, one H plus hydrogen ion is released. So as far as it is concerned to the equivalent weight of HCl, it will be equivalent weight will be molecular weight divided by 1. That is for monoprotic acids, equivalent weight will be equal to molecular weight, and this will be applicable for monoprotic acid like monocarboxylic acid. Monocarboxylic acid, it's a type of an organic acid. In organic chemistry, the physical and chemical properties will be discussed in detail related to carboxylic acids. Mono means again one, and carboxylic means COOH group, like HCOOH, commonly called formic acid. When dissociated, gives formate ion plus H plus, release of one H plus in its solution, monoprotic, like acetic acid, CH3COOH, when dissociated, gives COO minus plus H plus. For all the monoprotic acid, that is those acids, whether they are organic or inorganic, those that releases one proton, one H plus ion in its solution, their equivalent weight will be equal to the molecular weight because basicity of these acids is 1. Another monoprotic like HNO3 nitric acid, inorganic acid, H plus NO3 minus. Again here monoprotein 1H plus, therefore its equivalent weight will be equal to molecular weight. Now after monoprotein, diprotein. Di, it's clear from name, diprotein means two, like H2SO4, sulfuric acid. When sulfuric acid get dissociate, it dissociates as 2H plus SO4 2 minus. Since 2H plus ions are released, that's why it is a diprotic acid. Here, equivalent to weight of H2SO4 will be its molecular weight divided by 2. What is 2? Basicity of sulfuric acid. Since we know hydrogen equal to 1, sulfur 32, oxygen 16. Putting this value, we will get molecular weight of sulfuric acid 98 divided by 2. So 49 will be the equivalent weight of sulfuric acid. For diprotic acid, N dash will be 2. For dicarboxylic acids, these are organic acid like oxalic acid. Oxalic acid is COOH, single bond COOH. This is oxalic acid, molecular formula H2C2O4. Here dissociation takes place and oxalate ion along with elimination of two protons, two hydrogen ion in its solution. Since it's a diprotic acid, that's why its equivalent weight, that is equivalent weight of H2C2O4 will be its molecular weight divided by 2. We know carbon has atomic mass 12, hydrogen has 1, oxygen 16. Putting the value, molecular weight will be find out and it will be divided by 2. So ultimately we can find the equivalent weight of oxalic acid. After monoprotein, diprotein, now polyprotein, more than 2. Polyprotein, that is poly means many, more than 2. More than 2H plus released like H3PO4, phosphoric acid. Phosphoric acid get dissociate as 3H plus PO4 3 minus. Since here 3 protons, 3 hydrogen ion are released, therefore equivalent weight of H3PO4 will be its molecular weight divided by 3, because here 3 is basicity of acid. So, on the basis of number of proton H plus ion released in the solution, the equivalent of weight of acids can be find out. Next, after acids, the same is for the base. As per Arrhenius, bases are those that release OH minus ion in solution. Like the acids, bases also have the equivalent weight of base will be its molecular weight divided by N dash, and N dash is acidity of a base. What is acidity? It is number of OH minus released to neutralize H plus ion. So the number of H plus ion released represents acidity of a base. So for monohydroxide base like NaOH, strong base of alkali metals, Na plus OH minus. One OH minus is released like KOH, K plus OH minus. One OH minus is released. So here equivalent weight will be equal to molecular weight divided by 1, that is equivalent weight will be equal to molecular weight in the case of bases, strong bases of alkali metals. Now for dihydroxyls, those that releases 2OH minus, that is N dash will be 2OH minus are released like barium hydroxide, hydroxides of alkaline earth metals Ba2 plus 2OH minus, like magnesium hydroxide Mg2 plus 2OH minus, like calcium hydroxide here Ca2 plus 2OH minus. So far alkaline earth metals hydroxides, here equivalent weight of barium hydroxide, magnesium hydroxide, that is alkaline earth metal hydroxide will be its molecular weight divided by 2. Equivalent weight of alkaline earth metals hydroxides like barium hydroxide, magnesium hydroxide, calcium hydroxide, it will be the molecular weight of the base divided by 2, because its acidity is 2, they have tendency to release 2OH minus in their solution. Now for different metals like aluminium hydroxide AlOH whole thrice, Al3 plus 3OH minus, like ferric hydroxide, it becomes Fe3 plus 3OH minus. Equivalent weight will be equal to molecular weight divided by 3, because here these bases, weak bases, releases 3OH minus in their solution. After base, next we will discuss about the salts. What are salts? These are result of neutralization between acids and bases. Their categories: strong acid, weak acid, strong base, and so on. So in salts, the equivalent weight of salt will be its molecular weight divided by N dash, and here N dash will be total charge over cation or anion. Either we will take cation or we will take anion. Total charge over one part, whether it is cation or it is an anion, will be the N dash, and when molecular weight will be divided by total charge present over cation or anion, then equivalent weight of the salt will be find out. Like calcium carbonate is a salt. When dissociated, it gives Ca2 plus CO3 2 minus. Plus and minus are the charges due to release and acceptance of the electrons, but we will just add here the value as 2, not as plus and minus. Here total charge on cation is plus 2 and anion is minus 2, so the charge 2 will be considered. Therefore, equivalent to weight of limestone, that is calcium carbonate, will be its molecular weight divided by 2. Total charge over anion, either we will take cation or we will take anion. So since 2 charge is present on cation and 2 is present on anion, so it will be divided by 2. If we take like barium sulfate, BaSO4, it dissociates as Ba2 plus SO4 2 minus. So here equivalent weight of barium sulfate BaSO4 will be its molecular weight divided by 2 again, because total charge on cation is 2 and anion is 2. Let's see another example of salt, like aluminium sulfate Al2SO4 whole thrice. When it get dissociate, it results 2Al3 plus 3SO4 2 minus. Total charge is 6 at cation and 6 is at anion, not 3. One ion of aluminium has 3, so 2 has 6 charge. One ion of sulfate has 2 charge, so 3 ions have 6 charge. Therefore, equivalent to weight of aluminium sulfate Al2SO4 whole thrice will be its molecular weight divided by 6. Total charge over anion, whether it will be cation or anion. So this is the equivalent weight related to salts. Now last is oxidizing and reducing agent, like oxidants and reductants. For oxidants and reductants, it will be the equivalent weight will be molecular weight divided by N dash. What is N dash here? It is number of oxidation change per molecule. Number of oxidation change per molecule. So here N dash we will find out on the basis of oxidation number change, that is transfer of electrons. Let's see one example. When KMnO4, this is an oxidizing agent, in acidic medium, that is H2SO4, in acidic medium it gives Mn2 plus. KMnO4 gives Mn2 plus, or we can say MnSO4. Since the central atom manganese, for oxidation we know K plus 1 from oxidation number change from redox unit, and O is minus 2 in normal condition. So 1 plus X plus 4 minus 2 equal to 0. So 1 plus X minus 8 equal to 0, X equal to plus 7. So 7 plus is the oxidation number of manganese here in potassium permanganate, while here in MnSO4 since sulfate is minus 2, so Mn becomes 2 plus. So what is the oxidation number change from KMnO4 to MnSO4? It is 5 in number. 5 in number, and 1 manganese is present in 1 molecule. So per molecule, what is the change in the oxidation number or transfer of electron? It is 5 plus 7 converts into plus 2 after acceptance of 5 electrons. So in a chemical change from potassium permanganate to MnSO4, manganese sulfate in acidic medium, since here change in oxidation number of manganese per molecule is 5, Therefore, equivalent weight of potassium permanganate in acidic medium. We have discussed already that equivalent weight gets changed as per the change in the condition of a reaction. So it will be the molecular weight of KMnO4 divided by 5. What is 5 here? It is the oxidation number change per molecule. Now taking next, if the same KMnO4 is taken in basic medium, potassium hydroxide, basic medium, it converts into K2MnO4. We can note down this like in ionic form, change this molecular form into ionic form, MnO4 minus in basic medium converts into MnO4 2 minus because 2K plus. Now here x minus 8 equal to minus 1, x equal to 7 plus. Here x minus 8 equal to minus 2, so x equal to 6 plus. Putting the value here plus 7, 7 plus and 6 plus. So change in oxidation number from manganese as MnO4 minus to MnO4 2 minus, potassium permanganate to potassium manganate is 1, just 1. So in basic medium, equivalent weight of KMnO4 get changed in basic medium. It will be equal to molecular weight. Why? Because the change in oxidation number is 1, so it will not affect in the equivalent weight of potassium permanganate. That's why in basic medium, the equivalent weight of potassium permanganate will be the same as its molecular weight due to change in oxidation state of the manganese, just only 1 unit. While in previous example of KMnO4, when condition was acidic, then KMnO4 converts into Mn2 plus due to transfer of 5 electrons per molecule. The molecular weight was divided by 5 to find out the equivalent weight of potassium permanganate. Now, change the again condition of KMnO4. Now neutral. In neutral like H2O, it gives MnO2. Again, from here 1 plus x minus 8 equal to 0, so x equal to 7 plus. This is 7 plus again. Here x minus 4 equal to 0, so x equal to 4 plus. This is 4 plus. Change in oxidation number per molecule is 3. So in basic medium, equivalent weight of KMnO4, in neutral medium. In neutral medium, equivalent weight of KMnO4 will be its molecular weight divided by 3. So equivalent weight we have discussed already, it's not a fixed property of a compound or an element. It varies along with reaction to reaction or the condition changed. The example is before you. KMnO4 has 3 different equivalent weights in different conditions in acidic, basic and neutral medium. In acidic, equivalent weight is found out by dividing the molecular weight by 5, in basic by 1 and in neutral by 3. So KMnO4 equivalent weight will vary from reaction to reaction under different conditions. In acidic, divided by 5, in basic divided by 1 and in neutral divided by 3, that is ABN/513. So easily you can learn about the equivalent weight of KMnO4. Now about K2Cr27. Again another oxidizing agent, potassium dichromate, converts into Cr2SO4 whole thrice. Chromium sulfate. Convert this molecular equation into ionic form, it becomes Cr272 minus because 2 plus get dissociated, and here 3SO4 2 minus dissociated. So it forms 2Cr3 plus. This is the ionic form of this molecular equation. So find out this chromium. 2x minus 14 equal to minus 2, 2x equal to 12, therefore x equal to 6 plus 6 oxidation state. Here chromium has 3 plus oxidation state. So chromium from Cr2O7 to Cr3 plus is change in oxidation is 3 unit. 3 unit oxidation number change per atom. But since in one molecule of potassium dichromate 2 chromium are present, therefore 6 unit per molecule, and we will consider the change in oxidation state per molecule as per the previous equation. So there will be change in the oxidation state 6 units because in one potassium dichromate 2 chromium are present. One chromium has change in oxidation number is 3, so 2 chromium has 6 because 2 chromium are present in one molecule of potassium dichromate. Therefore, equivalent weight of K2Cr2O7 will be its molecular weight divided by 6. So, for oxidizing and reducing agents, it will be the total number of charge of change in the oxidation number per molecule will be considered. Now, take one chemical equation. Hypo, commonly called hypo, and chemical name is sodium thiosulfate. This is Na2H2O3 when reacts with iodine converts into Na2S4O6. This hypo sodium thiosulfate converts into sodium tetrathionate when reacts with iodine. So what is the change in the oxidation state of sulfur? Here Na plus, so 2 into 1 plus 2x plus within bracket minus 6 equal to 0. So 2 plus 2x minus 6 equal to 0. 2x minus 4 equal to 0. So x equal to 2. Here 2 plus is the oxidation number of sulfur per sulfur. And here 2 into 1 plus 4x minus 12 equal to 0. So 4x minus 10 equal to 0. So x equal to 10 by 4 equal to 2.5. So per sulfur atom change in oxidation number is here 2.5. So it becomes 0.5 per sulfur atom. Since 2 sulfur atom are present in one molecule of hypo, therefore 2 into 0.5, that is 1 oxidation number change per molecule. Therefore, in this equation, when iodine reacts with sodium thiosulfate and result sodium tetrathionate, the equivalent weight of sodium Na2H2O3 sodium thiosulfate will be equal to its molecular weight without any change, because there is change in the oxidation number of sulfur, just only 1. So this is all about for the equivalent weight. In part 1 we have discussed about the examples where hydrogen, oxygen, chlorine and silver displacements are noted. In the next part second, we have discussed in detail about the acid, bases, salts and oxidizing and reducing agent. So this is all about for the equivalent weight. Thank you.